Today we're going to talk about is thermal conductivity. This will be a lot quicker of a video than previous videos. Alright, so what we need to do is talk about the K value. Thermal conductivity is how fast something can go through a material. This is usually measured in what we call watts per meter per Kelvin. Now there's resistivity, which is the reciprocal or the opposite of thermal conductivity, and is measured by the opposite of heat transfer. It is measured in meters squared per Kelvin per degrees watt. K values, which are right here, so here's some thermal conductivities of different materials. So copper being at 399 is a very good thermal conductor, while air is at 0.026, a very poor thermal conductor. It's actually one of the worst conductors of heat. You can also see that cork and wood are very, very good at being thermal conductor insulators. So how do we calculate this? Well, the K value is amount of heat that gets transferred across a specific surface based on its thickness and how big that surface area is and what is that temperature gradient, what's that temperature difference between outside to inside. These are materials you'd have to get. This K value has to be done quantifiably. You can't, it has to be done experimentally. You can't just like mathematically come up with the K value. Notice that this is Q prime, or Q with an apostrophe. This is not the same as heat. This gets really confusing and I apologize, but Q prime is not the same as Q. Q is heat, while Q prime is heat transferred. So this is different. So we're now starting to get where you're like having multiple symbols, and now you're changing things a little bit. Now the inner surface of the plane of brick wall is at 40 degrees and the outside surface is 25 degrees. Let's calculate the K value of that brick wall per square meter of surface area of the wall, which is 25 meters thick. Okay, so I want you guys to do that. All right, so again, we go in, we say 41.6 watts is our K prime. Our width is 25. Now, this is important. It has to be 0.25 because it has to be in meters, not centimeters. And our area is 1 meter squared. And temperature differences between 40 and 25. So that gives us a temperature difference of 15 degrees, and we plug that in, and we get 0.69. So we can look at that 0.69, and we're somewhere near waters. Now, R value is the measurement of the resistance to heat flow. So that was conductivity of heat flow. This is the resistance to heat flow through a given amount of surface area. So the higher the R value, the more thermal resistance that material has. Therefore, it's a better insulator. So this is going to be looking at stuff that we're trying to figure out, is it a good insulator or not. L is the thickness of the material, measured usually in meters, and K is a thermal conductivity. R values are measured in meters squared per degree Kelvin per watt. Higher R value, the better thermal insulator it is. So the thermal resistance of a 22 centimeters of solid brick with the thermal conductivity of 1.2 is about 0.18. Now, what happens if you have multiple layers added? So if you have like a layer of brick followed by styrofoam insulation followed by this barrier, this water barrier, followed by some concrete masonry units. Well, what you can do is you can add those up, those R values of each individual components into each other. And if you do that, you can actually get a much better thermal conductor. So if you were to insulate the same brick wall with 8 centimeter thick foil facing polycyanoacrylate styrofoam with an R value of that, then all you have to do is add those two together and you can increase it a lot. So in this wall, it would have a total R value of insulation of 0.18 due to this due to the brick plus the styrofoam at 3.64, That gives us at 3.82. Therefore, it improved the thermal resistance 21 times by just adding this little simple piece of styrofoam to the backside of that brick. We can also look at all these here, and here's all our R values for the different stuff, and we can add all of those up, and we can get the actual R value of that, and we can figure out how much thermal resistivity there is to that wall. Now, U value of a building's element is the inverse of the total thermal resistance of the elements. The U value is measured on how much heat is lost through a given thickness of a particular material, and it is included in three major ways in which heat is lost due to either conduction, convection, or radiation. This can be calculated by taking the reciprocal of the total R values and then adding a little bit of the convection heat loss and radiation heat loss, which we won't deal with. So we can actually take the 1 over all of the R values together, and that's going to give me our U value. If you're confronted with thermal conductivity, R values and U values going forward, here are three simple things to remember to make sure you get the best insulation in your products. Higher the numbers are good when comparing thermal resistivities, or R values. So when you go to the store like Lowe's, look at the insulation. There will be an R number on it. It will say R33, R10, R15. The bigger the number, the better the insulation is. It's going to protect it. The lower your U value is better because it's going to hold on to that heat better. U value is the most accurate way to judge a material's insulation ability, because it's taking into all the accounts of the convection heat loss and radiation heat loss. But R value is a lot easier to calculate and thus is used more commonly in the stores. So we can then calculate the U value looking at the R values here of different materials. So we have a brick cladded wall, gravel, concrete, air gap, air, cement board, fiberglass, insulation, and 3/4 inch cement board. So we can look at this. So we have our values. Now remember, some of these values, like let's say this is for a 2x4, 2x6, or wood siding for 1/2 inch. So if you have twice as much, you're going to be twice that value. If you have half this much, you're going to have half this value. So you got to remember that if, like for instance, we have our concrete is 3 inches, concrete's only for 1 inch, so we need to triple this number. So what I want you to do is try to actually calculate the U value for this particular wall. All right, so what you're going to do is you first have to figure out the R value by just adding them all up. Again, we're multiplying things because there's 3 times as much fiberglass, concrete 3 inches, and then we have half as much gravel, and the brick, also the same thing with the brick, is twice as thick. That comes out as a total R value of 13.55, and then we just take the inverse of that to get our U value, and 13.55 inverted is going to give us a 0.07 U value. And again, that's excluding convection and radiation due to the wall. So if you have any other questions, write them down and ask me in class.